Hello and welcome to another video by YCSC Lab. This is going to be a quick demonstration, and in this demo we'll be developing a working exploit for Zip and Go 4.9. So let's move to the lab. So this is the exploit available on ExploitDB, and it's vulnerable to buffer overflow, and it was written by Hashim Jawad. Now you can download the vulnerable application from here. This link to ExploitDB is mentioned in the description below, and we are going to create this exploit from scratch. So let me close this window, and the first step is to generate test zip files in order to fuzz zipandgo.exe, which I have already downloaded. And let's generate the zip files. So I have a fuzzing script to generate sample zip files here. It's written in Python, and I'll use python zip.py, and it will generate 50 sample zip files. So I'll select them, and let me just copy them here to a directory in my C drive, which is fuzz. And now I'll use file fuzz to fuzz this application. So here I'll select zip first, remove zip from here, and nothing else we need to change. And here I'll select the path to the application, which is on my desktop, zipandgo.exe. I'll remove this, and our file names are from 1 to 50. So I'll specify that here. Let's and clear the log and execute. So you can see that crashes are appearing here, and then let this application run to finish all test cases, and then we'll analyze the crash. So you can see that the first crash appeared at 7.zip. So that means that seventh sample file generated the crash, and from here onwards we have 8.zip, 9.zip, and then I skipped some cases in between, and then 25 onwards we have till 50.zip. And if we analyze this crash, you can see that EDX has been overwritten with 41, 41, 41, and all the remaining registers seem to be holding some value which is not controlled by us. So let's try to replicate this crash. So based on this crash, I've created a POC here, and it will generate a sample zip file which will trigger the crash in this application. So let's generate that file by running the script. Write python zip poc.py, and you can see that test4.zip has been generated. So let's open this application in Immunity Debugger, and zip and run this application. It's okay. Don't display this next time. Now let's open our test zip file. Okay, so you can see that application has crashed, and EBP is pointing to a buffer, and EDX has been overwritten by a buffer. Now if we see the SEH chain, you can see that it has been also overwritten by a buffer. So if I pass the exception to the program using Shift F9, you can see that EIP has been overwritten. So we can exploit this crash. So next step is to find the offset of EIP. So let's do that using Mona library. I'll use Mona, and PC 4500. So Mona has written this into my working directory. So I have updated my POC with this pattern. Let us regenerate this file. Let's run this application again. Okay, and then open this file. Let's pass the exception to the program, and you can see that EIP has been overwritten this value. So again, let's use Mona library to find MSP. So you can see that SEH record or an SEH field at this address has been overwritten with pattern, and the offset is 3892 followed by 600 bytes of cyclic data. Alright, so this seems to be the offset that we need to write to. Let's verify it. So I've again updated my POC with the proper payload. Let's generate the new zip file and run this application again in Emulator Debugger. Run it. Okay, and then let's open this zip file using open and zip archive test4.zip, and then let's pass this exception to the program, and you can see that EIP has been overridden with 43, which is hex for capital C. So that means our offset is working. Next, we need to find out the pointer to pop return instructions. So let's restart this application again, run it. Okay, and we'll again use Mona library, Mona SEH, and let's go to log window. You can see that it has found a total of 276 pointers, and we can use any of these pointers. So let me select this, copy to clipboard, message part, and then I'll update the POC with this address, and then we'll see if it works or not. So I've again updated my POC with this address. Let's regenerate it, and let's go to CPU window and put a breakpoint at this memory address, and now open this file in zip and go, zip archive, and let's pass this exception to the program, and you can see that we have hit a breakpoint on pop-up return instruction. So that means the memory address is working, and if we go here, we have landed on NaCH, and you can see that here is a buffer of around 600 bytes, and above this is a buffer of around 3000 bytes. So we'll use this. So we'll use a short jump backwards and then a long jump backwards. So let me update our POC with those jumps. So I've updated the POC with a short and long jumps. Let's regenerate the POC file, and let's relaunch this application in Emulator Debugger. Run it. Okay. Let's first put a breakpoint at the pointer to pop-up instruction. It's already there. So let me open this file now. And I've used test4. Application has crashed. Let's pass this exception to the program. We have hit our pointer at pop-up return. Then we are taking a short jump of 20 bytes. Then from here we are taking a long jump of 400 bytes. So now let's do the bad character analysis. To do that, I'll use Mona library. So I'll use Mona byte array, and I'll exclude the characters hex00, hex0a, and hex0d. So I'm considering these as bad characters by default. Generate the byte array. So you can see that it has written it to the Mona working directory. So let me just copy this array and include it in a POC. So I have updated the POC with byte array. Let's regenerate the test file, and in Emulator Debugger, let's relaunch the application. Okay, run it. Now let's open the zip file in it, zip archive. Let's open this file. Let's pass the exception to the program. Now we have hit our breakpoint at pop-up return. Let's step into it. Let's take a short jump. So now we have landed on the byte array. So let's see if we have any other bad characters. To check that, we'll again use Mona library, and we'll use Mona compare, and I'll specify the file name, which is c mona byte array dot bin, and then address will be 0012 fbdc. rather DA. Let's compare it. So you can see that it says unmodified, so that means our byte array has been sent as is. And if we check the log window, so it says that hooray, normal shell code unmodified, so that means there are no other bad characters. So we can safely go ahead and generate our payload shellcode and include it in our POC. So to do that, I'll go to my Kali machine and let me generate the shellcode using MS7M. And post 192.168.663 equal to 4444, and bad characters are x0t, and format is Python. So our shellcode has generated. Let's just copy this, and now I'll update the POC with this shellcode. Now I have updated the POC with the shellcode. Let's regenerate the file, and let's again go back to Kali machine and set up multi-handler, then run. And now finally let's go back to our XP machine and let's regenerate this file, go back to Immunity Debugger, rerun this application, and let's open this zip file in this application. Pass the exception to the, and as you can see that we have received a reverse shell here. So that was a very quick demonstration on how to write exploit from scratch. If you want to learn the art of exploit development, do check out our hands-on courses. They cover from basic techniques such as stack-based buffer overflow, SEH override, to advanced techniques such as egg hunters, ASLR bypass, Unicode exploits, stack pivoting, function reuse, and our advanced course also covers on how to write exploits for complicated file formats such as the zip file format from scratch. And also check out our free course, which is Immunity Debugger for Exploit Devs. In this, I give you a detailed walkthrough of Immunity Debugger, and being familiar with Immunity Debugger will really make your life easy as an exploit developer. You can enroll for our paid courses at only Rs 640 or $9.99 by using the coupon code NEXTSTEP during checkout. The link to these courses along with coupon code is mentioned in the description below. Thank you for watching this video, and I'll see you in the next video very soon.